Green power refers to grid source off-site renewable energy. EA Credit 6, Green Power, has 2 points available for new construction, schools, and core and shell. The intent is to encourage the development of grid source renewable energy technologies on a net zero pollution basis. The requirements are to provide at least 35% of the building electricity from renewable sources by engaging in at least a 2-year renewable energy contract. Exemplary performance credit is available for purchasing 100% of your energy costs for a 2-year energy contract. Based on quantity of energy consumed, not the cost, which is different from optimizing energy performance calculations. And your standards, which are important to memorize, is the Center for Resource Solutions and also the Green Products online resource. So this is how you find out if renewable energy certificates, RECs, tradable renewable certificates, or green tags comply with this requirement. It's really third-party verification that those funds are going towards some sort of solution for renewable energy or to help the environment on a large scale. So when I have a client ask me if they can buy a LEED credit, that's the only one I mention. Documentation. It's based on the quantity of energy consumed, not the cost. As mentioned before, this is important to understand because it is different than the optimizing energy performance calculations and also on-site renewable energy calculations. The standard, Center for Resource Solution, and Green Products. Review there because that's important to memorize for the exam. Renewable energy certificates, tradable renewable certificates, are becoming almost like the stock market. This is really changing the market. For schools only, school districts can buy the green power, then designate one project for it. The same power cannot be credited to more than one project. The letter from the power company owner providing this is required. So this is for school districts investing in green power. For core and shell only, the core and shell building electricity use for the core and shell square footage is defined by the Building Owners and Managers Association, BOMA standard. And to calculate the building's core and shell square footage, subtract the usable square footage from the gross square footage as defined by ANSI BOMA standard Z65.1. So it's gross square footage less usable square footage over gross square footage times 100. And it must be at least 50% of the total gross building square footage. Option 1, similar to optimizing energy performance, you need to first determine your baseline electricity use. So use the annual electricity consumption results from EA Credit 1 as one option, or estimate baseline electricity use. This can be determined from the U.S. Department of Energy's Commercial Buildings Energy Consumption Survey database. It's important to memorize that standard. It's also a good standard just to check out. This gives you a snapshot of what the results were from that Commercial Building Energy Consumption Survey. It's a survey of hundreds of buildings across the country, comparing buildings of similar types and looking at their median electrical intensity based on kilowatt hours per square foot per year. So you can see that food sales are one of the highest, which is why you saw results with Fred Meyers that are instigating results across the country in retrofits because they're seeing that cost savings. Inpatient healthcare is second. You can see education is really relatively low in comparison, but it's still important to do energy upgrades and investments in renewable energy to be future ready. There are 3 implementation options. 1, buy power from a greenie provider in states with an open energy market. Using this choice requires signing a 2-year contract for at least 35% of the building's estimated annual electricity. So remember that number, 35% for a 2-year contract. Second, in states with closed electricity markets, purchase power from use a Green E accredited utility provider may require paying a surcharge or premium, and you need to sign a contract for a 2-year minimum. Third option is to purchase Green E renewable energy certificates, RECs, in areas where Green E power cannot be bought. So using a single or series of purchases by RECs equal to 35% of the estimated annual electricity for 2 years. So that percentage stays the same. It's just how you purchase that energy depends on the state you're in. This graph shows the annual renewable energy electric capacity growth from 2001 to 2008. Wind grew 33%, solar PV 37%. This graph shows renewable electricity generating capacity worldwide, starting with biomass, then wind, and geothermal, and PV. Some fun facts about solar. Solar energy electricity generation has more than tripled between 2000 and 2008. Countries with aggressive solar policies such as Germany, Spain, and Japan lead the world in solar voltaic deployment. Similarly, U.S. states with aggressive solar incentives lead the United States in installations, California, New Jersey, Nevada, and Colorado being at the top. U.S. manufacturers currently have a small share of the world PV market. Qcells, based in Germany, was the market leader with 8% of the global PV market. This shows that you don't have to have sunshine all the time to be a leader. In fact, PV panels are more efficient in climates that are not too hot. Now, although no concentrated solar power plants came online in 2008, there are currently about 80 megawatts of concentrated solar power under construction. So more recent data is hard to find, but this gives you an idea of the trends. There are disparities in that data, but it's important to see what is going on worldwide. And those are some examples to give you an idea of the bigger picture. There are various solar technology types. There's the parabolic troughs that focus solar radiation onto a linear receiver. And that tube often has synthetic oil in it that heats up on a large scale that can feed into something like a solar absorption chiller for district heating and cooling. We were looking at that in an option for our LEED neighborhood development pilot project in Dubai. And it definitely took economies of scale to make that work. Concentrated solar dishes focus solar radiation onto a point focus receiver. And a central receiver is a field of plane mirrors or heliostats that all move independently to keep a beam of solar radiation focused on a single receiver. Less common, you see those sometimes in Spain. Here's some real snapshots of those different innovations. Here's an example of solar electricity generating system of a parabolic trough type of system. To look deeper at the mechanics of the SEGs, the mirrors automatically track the sun throughout the day. So you have to think about maintenance there, but you get a lot more efficiency when you're actually having the mirrors move with the sun. And the parabolic mirrors are shaped like a half pipe. The sun bounces off the mirrors and is directed to a central tube filled with synthetic oil, which heats to over 400 degrees Celsius or 750 degrees Fahrenheit, which is why it's a good strategy for fueling something like a solar absorption chiller or used for other types of systems. Another innovative strategy is a solar power dish. which also integrated a Stirling genset engine. It was called the Suncatcher. The Suncatcher was interesting because it blended old technology with new. You had the dish's mirrored reflectors, and then the genset engine is something that's been around for over 100 years. It just includes hydrogen gas that expands and drives pistons, generating electricity within the engine that's directly attached to the dish, so there's no efficiency loss. A lot of times PVs are not as efficient because you actually lose a lot of that electricity in distribution. To put in perspective how much more efficient the Suncatchers are, one dish can power up to 10 homes. They're a little out of scale at this time, but as technology continues to improve and mass production happens, we might be seeing some things like this in our yards or in our buildings. Here's a diagram of holistic design. We see wind-driven ventilation with heat recovery. Ask yourself, is that renewable or is that just optimized energy efficiency? If you said optimizing energy efficiency, you are correct, because it's not actually producing electricity, it's just helping make the building more efficient through heat recovery. Rainwater collection that could be reused for toilet flushing, which would help with innovative wastewater and water use reduction, and also for irrigation, reducing potable water. So two synergies with water efficiency and also with sustainable sites for stormwater management. You see a car plugged in that has a synergy with sustainable sites as well for alternative transportation. PV to charge electric car that is on-site renewable energy, opposed to the wind-driven ventilation with heat recovery that's just optimized energy performance. So once again, keep testing yourself with how these credits interrelate to each other through these various strategies. Synergies is a very important part of the exam. The Center for Health and Healing in Portland OHSU campus is a great example of integrated design. They have things such as overhangs with PV panels on the south side, so you actually get a blockage of the direct solar heat gain in the summertime with those sharp summer rays. When the rays are lower, more horizontal in the winter, you actually get the light coming in and don't have to use your electric light as much, and also the energy production from the PV panels themselves. Daylighting was important. There's studies that actually show that it helps with healing as well, in addition to energy efficiency. Exemplary performance for energy and atmosphere includes EA Credit 1, optimized energy performance, one additional point for 50% more efficient than the ASHRAE 90.1 code, or 46% for building renovations, totaling 20 points possible for that one credit. Remember, it's the most heavily weighted credit in the LEED New Construction Rating System, version 3. EA Credit 2, on-site renewable energy. There's an exemplary performance point for 15% of annual building energy costs being produced by on-site renewable energy. For Core & Shell, it's 5% of annual building energy costs. So new construction schools have 8 points possible for that credit, second most heavily weighted credit, the LEED New Construction Rating System. For EA Credit 3, enhanced commissioning, commission the building envelope to possibly earn an exemplary performance innovation design point. And for Core and Shell projects, you can use both fundamental and enhanced commissioning on all tenant spaces to earn this ID point. Lastly, for EA Credit 6, green power, if 100% electricity from renewable sources is purchased with a 2-year contract, you can earn an extra exemplary performance point. End of energy and atmosphere section.